Hey everyone, this is Matt with Learn Everything About Design, and in today's video, what we're going to be doing is talking about plasticity and fusion. Now, I get questions a lot because we cover both of these programs on the channel, asking what is the right program to choose? Can plasticity do this? Can fusion do this? And it's difficult. In a professional capacity, very rarely do we have one program that will do it all. So we need to jump around to different programs depending on the need. And so what we're going to talk about in this video is this request came in, I think this week, somebody asking about modeling this. It's basically a PVC conduit junction box. And it's a good example for us to talk about because it highlights some of the benefits or the pros and cons between using fusion and plasticity, depending on what you want to do. And so an example like this is generally going to be something that is controlled by dimensions and needs to be updated to different sizes, different families as there would be. And so when we look at something like this, what we end up having is basically various dimensions that need to change to alter the size of the part. Now, if you're drawing this or you're modeling this in a professional sense, typically it would also have draft. There's a parting line right in the middle of these, basically each of these inlets. There's going to be screw bosses on the inside. And I'm not going to go through the entire design for manufacture because really we're not going to be modeling this for manufacture. You could do both in plasticity and in fusion. But the goal of this is to really highlight the difference in approach when we're modeling something like this, and then also trying to highlight those benefits, those pros and cons. So we're going to start in plasticity, going to begin by creating a new file and deleting the cube like I always do. I'm going to go to perspective, which I personally prefer. And I want to note that I have my unit set to inch. And this is because this style of connector, this conduit box, it's a Cantex Type LL. It is driven by imperial numbers. So we're going to be using the inch unit system for this. Now, whenever we are starting to model something, it's always good to double check your units. You can enter units in basically alternate unit dimensions. So if you're in metric, you can enter IN for inch. If you're in inches, you can enter MM for millimeters when you're doing numerical inputs. That all aside, we're going to stick with the units that are going to be given in an image. I will also say that you can find these dimensions anywhere online. When we get into Fusion and we're actually making a configuration, I'll put an image on the screen. But if you just search for Cantex Type LL conduit body, you're going to come up with a detailed drawing and a list of all the different dimensions. So what we're going to do in this case is we're going to go to a top view. Now you can do this a couple different ways. And if you're just getting started in plasticity, we just released a new absolute beginner course for plasticity on our website, learneverythingaboutdesign.com. I'll put that information in the description of the video. But if you are trying to learn plasticity, that's a great place to start. We go through the basics of all these different steps, like setting up the UI, using curves, building solid bodies, and things like that. So basically on the right-hand side, if we go down, we're going to turn on 2D snapping because we want it to snap to a 2D plane. And then we need to pick the plane that we're going to be using. And we want the top, which is going to be XY. When we click that, we're activating the top plane. And if we double click it, it'll go to a top-down view. I'm going to try to avoid shortcut keys for these videos so we don't have to worry about that. But there are different ways to do that, like the number 7 on your numpad. Next, I need to define a line that's going to represent the, basically, we're going to be creating a slot. Now, the way that these things are defined, we're going to be making a 1/2 inch size. The way that these things are defined is typically by the overall length, which in this case is 4 inches. And so I'm going to hit tab, 4 inches. But the problem with this is that it's not going to give us the correct line for a slot. So when we're trying to draw a slot, we also need to remove the diameter or really the radius on either side. So we're going to subtract, in this case, the diameter of this part is going to be 1 5/16. So we're going to subtract 1, and then we're also going to subtract 5/16 and hit enter. Now that looks tiny. If we zoom in and we click on this line and we go all the way to the bottom here, it'll tell you the curve length. 2.687 inches, so it looks like that's okay. I also want to move that to the origin. I want it to be down here. So I'm going to use the move command. And I want to move it from that center point to this center point. And in order to do that, we want to use freestyle, which is F on the keyboard. So we'll select that midpoint and we'll move it down there and right click to accept. We want to zoom in. You can do this with your mouse wheel, or you can hit the / and it'll zoom into your line. Now that we have the line, the next thing that we want to do is create a slot. And so we're going to search for slot. And as we begin dragging this out, this is going to create the shape of this Cantex Type LL body. The diameter of this, or the width of this, is going to be, in our case, it's going to be 1 5/16. Now, whenever you're doing dimensions like this in plasticity, if you have a fractional dimension like this, 1 5/16, in some programs like in Fusion, you can put a space between the 1 and the 5, and it knows that it's going to be 1 plus 5/16. In plasticity, I found that you have to add the plus or the minus just to be consistent. Because if we just do 1 space 5/16, it thinks it's 15/16. So we'll enter that, and we'll hit enter. Now we've got basically this object. We don't need the line. I'm going to hide it, but we've got this slot body. We're going to get off of our top plane, and we're going to begin pulling this up. So the overall height of this is going to be 1 plus 7/16. Again, I'm pulling all these dimensions directly from a detailed drawing, which we'll take a look at in a bit. If you just do a search online for Cantex Type LL conduit bodies, you'll find plenty of images that have dimensions on it. So this is the base shape. And we're going to have a port that's going to be coming off of here, and we're going to have one coming off the side. The way that these things are designed, the diameter of this is going to be tangent to the bottom, and it's going to be along this edge right here. And so what I'm going to do with that selected is I'm going to make a plane from selection. We're going to zoom in, and I'm going to create a circle, and I'm going to begin dragging the circle down, and I need to define the diameter of it. So we're going to hit tab. And the diameter of this is going to be based slightly on the diameter of 1/2" PVC, which is not actually 1/2". The trade size 1/2" does not represent the actual diameter because, of course, why would it? Now, as PVC pipes and as Schedule 40 and Schedule 80 pipes change sizes, that does shift as you cross a certain point outside of the purpose of this video. All right, so the actual diameter of this is going to be 7/8, but that is the inside diameter for the PVC, the 1/2" PVC to fit into. And so what we actually need to do is we need to add the wall thickness. And again, based on specs, the wall thickness changes based on the size and the schedule. I'm just going to add 0.1 to this for basically just to make this video a little bit easier. There is a whole table that you can go and look at minimum size thicknesses. Unless you have one of these parts to measure in hand, that thickness can vary a little bit. So when we created this circle, it snapped to that vertical edge, and it basically now needs to move down so it's tangent. And there are a couple ways that we can do this, but generally the way that I do this is with move. And I'm going to use the freestyle option again. You have to hit F on the keyboard. And I want to move this bottom point straight down until it hits that bottom edge. So now it's tangent. I'm going to rotate this around, and I want to take this profile and begin pulling it out. I'm not going to worry too much about the actual dimensions for this stuff. You can enter 3/8, 0.375 if you want. The other direction is going to be negative going into the body. And at this point, what we could do is use the options to union these together by hitting Q. So you can hit Q on the keyboard, select this body here, right click, and now we still have a single solid body. I'm going to hide that circle. The next one that we need to do is coming directly out of the center of this side. Now, we don't have the ability to create a temporary construction plane on that curved face. So what we're going to do is we're going to be using the YZ plane. So I click the view cube here. Again, you can also do that by clicking here in the plane section on the right hand side, or you can use shortcut keys on the numpad 1, 3, and 7, or Control 1, Control 3, and Control 7 will typically get you there. So then we're going to create another circle. Now remember that we've got 2D snapping on, so even if we hover over this face right here, what happens is it's actually snapping to that YZ plane. If you turn off 2D snapping and you hover over this, note it says face. And if I create a circle here and I rotate this around, it's somewhere out in space wherever I clicked. And so that's not what we want. We want to make sure that we use that 2D snapping option because that's going to ensure that whatever we draw is going to be snapped to that plane. And so I want to make sure I snap to that Y-axis and draw a circle. I'm going to hit Tab. Again, this is going to be the sort of trade size of 1/2 inch. It's actually going to be 7/8. And I'm going to add that 0.1. And then we're going to use move again and freestyle. So F, we're going to move that point down so it's tangent. There are, as I mentioned, there are plenty of other ways to do this. And if you get comfortable with shortcut keys, this is quite a bit quicker than what we're doing here. The next step you have to be careful about is when you have a circle or a curve like this, if you just know the shortcut key for extrude and you hit E for extrude and you begin pulling this out, what you're actually getting is a sheet or a surface. So we need to actually go in and select the profile. So to do this, what I'm going to do is hide the solid body, begin pulling this out, and then I'll show the solid body again. Again, I'm not going to be too worried about exact dimensions here because I don't use plasticity to make dimensionally accurate production parts, if that makes sense. If we were just trying to make some concepts that were loosely the right size and shape, let's say maybe we wanted to 3D print something, then we would put precise dimensions in for those aspects. But in this case, I'm just going to pull it out till it looks about right and right click. Notice that in this case, I forgot to combine them together. It's still selected, so we can just use the Boolean tool, select the main body, but then we have to hit Q, which is union, or click union in the operations, right click, and now we've got our solid. So now we need to make this hollow. And to do that, we need to select these end faces. I'm going to hold down Shift, and then I'm going to search for hollow. And then I'm going to enter a value. Positive is going to thicken this outward. Negative will go inward. So I want that negative 0.1. That was that wall thickness value that I'm assuming or I'm using as sort of the rough value for a 1/2 inch Schedule 40 part. And now we've made essentially the shape that we want. There are a couple of other things that we want to do. At this stage, I personally prefer to turn off X-ray mode, so I'm not looking at all the edges inside. It really helps me. And then what I want to do is I want to create the smaller portion where the PVC is going to get pressed in. You can do this by creating a temporary construction plane and creating a circle with the correct dimension. What I'm going to do is just use offset, which is O on the keyboard. You can also come into these menus and find offset curve. I find that this works fine when you're dealing with curves, but when you are dealing with a solid edge selection, if you hit this, it makes it a little bit trickier. So I usually just use the shortcut key, and I do suggest you get comfortable with that. So what we could do is we could just figure out what size we wanted, and then now we've got an edge where we can just pull this inward. And that's essentially going to be the section where the PVC would get glued in. Now, in reality, again, manufacturing, there would be a parting line on the outside of this right at the center. These would have draft on them, but we're not going to account for that. If you did want to make it a very specific size, once again, you can select this face. You can make a plane from selection. You can add a circle that's centered there, and you can hit Tab to enter the value. In this case, again, it's 7/8. And now we've got the exact size. Instead of this being a split line on the face, we need to select this and pull this inward. And then we would use the option to do a difference, which is W, and it would cut it away. And so when we do that, when we use those tools like difference, you always have to remember to make your selections. I did not select it, so of course it didn't take it away, but that's okay because we can select it and use Boolean and then get rid of it there. The last thing that we need is just kind of a rounded edge on the bottom. So we're going to pull a fillet out, hold down Control to select the other side. And these typically don't have a fillet around the inlets that go into the conduit body because there is a parting line here. That would make manufacturing a little bit tricky. But again, for our purposes in plasticity, you could very easily add those if you wanted to. What I will say is, I'm going to hit escape on this. What I will say is we need to remember that plasticity is a direct modeler, meaning if you need to change the location of, let's say, this needs to move a little bit, we would use the move command and then we would slide it wherever it needs to go. There is a limit to how far this can go. For example, I am going to have a limited range of where that, you can see I can't pull it past the outside of that, of course. I can pull it down below it and it allows it to work, but I can't pull it past the right side, essentially because this would just extend on forever. It doesn't have anything to stop it. And we can drag it to the left, but once we get past this seam, it tends to start having problems. So again, there is going to be a limit to how much you can do with direct modeling, but that is the general process that we would have in order to modify the shape. So I'm going to go ahead and just add that fillet on the bottom, right click, and now we've made the shape. So that process took a little while, probably about 15 minutes in the video. In reality, with shortcut keys and knowing the process, it takes less than 5 minutes to do. So anything, it's always going to take a little bit longer when we're working through the process. So if you are looking for plasticity, then just keep in mind that there is no parametric history, even though we have measure distance and dimensions and we can use those to manipulate. So for example, we could pick the inside here and actually I'm going to go here and we can use tools like dimension and manually change the side of that. Let's say it needed to be 0.89. We can increase or decrease that. And so that's helpful when you're doing things like quickly making a concept and maybe you do need a very specific dimension there. You see this one, it's not working on this one because it was created from the offset, where that one was created from that circle. So again, there are limitations to this. It is a direct modeler. It's not a parametric modeler in the sense where we've created a sketch. But if this is the kind of modeler that you want, keep in mind we are an affiliate. You can use the code LEAD10 at checkout. That will save you 10% and does help out the channel. And again, I'll put the information to our latest release, the Absolute Beginner's Guide to Plasticity. It is roughly 2.5 hours of video that walks through a lot of the basics, the core features that you're going to use to model pretty much everything. We covered pretty much, I'd say probably about 25 to 30% in this video on the tools that we would use in that course. Now, when we hop over to Fusion, again, the process is different. And that's because with history turned on, we have a timeline, which is keeping a chronological order of everything that's been done. We also have sketches that we can go back to. In this case, I actually have parameters that I defined based on a detailed drawing. And the process allows us to do things like make various configurations or families of these parts that we can then go back and make changes to. We can have just a single file that's the source of truth, and we can have it update based on the selection and what we need. And so now we're going to walk through how to do this in Fusion. So we'll model the part using those parameters and the sketches, and then we'll create some configuration so we can understand how that process works. The main thing to keep in mind is underneath the hood, the geometry is still the geometry. The math is the math that creates the geometry. But the way in which we control it is just fundamentally different. In one method, we're really looking at all the dimensions at the start. We're building out a robust model that can be updated and changed at a dimension level. And in plasticity, we're really looking more at a direct modeling approach where we can use numerical inputs. We did make the body the right size. We do have the ports that are the right size. But at the end of the day, what we're really doing is we're creating a direct model where we don't have that same history. It gives us a little bit of freedom in terms of what we can and can't do for geometry. We can create some pretty complex shapes that otherwise would be a little bit difficult for us to do in Fusion. So I just have a new part file. In this case, it's doing a part design. It could be a hybrid design. It won't really matter in this case, but you do need either a part or a hybrid design. And I just imported this as a canvas. Again, just a quick search online. Cantex is going to be the brand. You're likely going to find all sorts of different electrical suppliers that will just reference this drawing. What we're going to be doing is creating the top three, the 1/2 inch, the 3/4, and the 1 inch versions of this part. Again, these are the numbers that we used in plasticity, the 4 inches, the 4 1/4, and so on. When we look at this drawing, it doesn't actually have all the dimensions for us, so we're going to make some up as well. We're not doing a lid or a gasket or even the bosses for the screw, but we will get the general shape like we did in plasticity. So when I start a design like this, I always think about what is the end goal for the model. If I just need the model and I don't need to worry about going back and updating it, then I may just kind of brute force it and not worry about sort of planning it out ahead of time. If I know that I'm going to be making, let's just say, all of these in a single file that's configurable, then I'll spend a lot more time on the front end of it, adding all these dimensions and sort of building it out. This is a tricky part to do that with, because after you get up to the 2 1/2 inch size, which is fairly large conduit size, the rounded body of this actually turns into a squared body, which means that if you are factoring that in, if you're trying to make a single file that does all of these, if you're factoring that in, you need to be careful with doing things like referencing the edge of the fillet for the location of the port, and you need to use a lot of other dimensions to drive that. Instead of creating a slot shape, you would create a rectangle and then add a full round fillet to the smaller ones, and you would suppress that in the larger ones. That would be a little bit longer of a video to account for all that. So we're going to just focus on the first three. Really, it could be everything up to the 2 inch size until it changes the shape. It would be totally fine for this. But we're going to start with modify and change parameters. Now, the change parameters, every time you create a sketch, create a feature, the dimensions are stored in what's called a model parameter. We also have the ability to pre-create these, and we've done loads of videos on this in the past. We've talked about these parameters for things like API access and using XML files for building out different models. We've talked about configuring designs with things like if-else statements inside of here. So this is not new to the channel, at least, but if you never used parameters before, then really we want to think about these as just the dimensions that we're using to control our model. And we're going to start by first making sure that our units are correct, because the units in the file are going to make a big difference, especially once we start to get into things like using mathematical operators inside of change parameters. It just becomes kind of a pain to always have inch type IN if the document units are metric. When we start inside of here, we're going to hit the plus. It's always going to pop up this little parametric text thing. I leave it on just because I make videos, and if I don't, that it'll never pop up again. But we do have the ability to configure text in here as well, and I could do a video on that. I did a little script for to show a client to actually configure the text based on the mask properties. It's kind of a pain, but we can show it if people are interested. All right, so the first thing that I'm going to do, generally I would give these names like width or height or length or thickness. In this example, I'm just going to use A, B, C, D, and E. It'll be easier for us to go back and reference. So the first one I'm going to do is I'm just going to put A here. Notice that it gives me a red bar because it does not like this as the only name. So you might need to put DIM_A, something like that. If you have the blue bar underneath, it'll accept it as a valid name. Next is the expression. This is just the number. And again, in Fusion, what we can do is 1 space 5/16. Again, red bar underneath will tell you it doesn't accept it. Blue bar, it's fine. And it shows you the value here. So we can see that it's actually 1 plus 5/16 and not 15/16, which would be less than 1. So you can kind of validate that here. And we'll say, okay. So now we got our first dimension. The star, you can use that to add it to your favorites, but user parameters will be at the top by default. If you have model parameters, things like dimensions and sketches, whether or not they have names associated with them, you can use the star to put them in the top. Otherwise, they're just going to be buried in a list. All right, next we're going to do DIM_B. You don't need the underscore, but there is a limit to what you can do inside here. You can't do a dash. You can't do a space. So you need to either just use capitals to divide that, or an underscore is generally how you would do it, just for simplicity. All right, dimension B, 1 7/16, pretty straightforward. We're going to do dim C, and C is 4 1/4. And you can also manually enter 0.25 if you want. I'm going to enter them exactly like they are in this list. That's how they're going to show up in the expression, even though it gets evaluated as the decimal. All right, so we've got A, B, and C. We're going to do dim D. This is 4 inches, pretty straightforward. And we're going to do dim E. Should be our last one. And that's 7/8. I am going to add another parameter here called, I'm going to do wall underscore thick. Again, this value varies. I'm going to just use 0.1 for now, but I want this value because one, we need it for dimension E, which is the sort of port diameter, because we need to add the wall thickness, not included in this detailed drawing, so we're just going to kind of make it up. But if you do happen to look around, you're going to find like 1/2 inch schedule 40 is around 0.1, 0.109. 3/4 schedule 40 goes up to about 1/8 of an inch. When you get to 1 inch, it's getting more. Basically, each time you go up in size, the wall thickness increases. So we're going to have this parameter here so we can change it as needed. All right, so now we've got our parameters. This is just an image here. That's our reference. We need to start creating the design. When you're creating a design for just general purposes, sometimes you don't really have to plan it out as much as you do with a configurable design. But we're going to do the same approach that we had for basically making the one in plasticity. I'm going to do a top-down view. And from my top-down view, I'm going to go to my line tool. And this time I'm going to use a midpoint line from the origin and drag it out to the left. Now, on that detailed drawing, it gives us the overall width as value D. So I'm going to start typing dim for dimension, and I'm going to enter D. But that is the overall width of our part. And if we're going to use a slot and not like a center point rectangle with a fillet around the outside, then it's important that we get the correct value. So what we need to do is we need to minus dimension A, which ultimately is the diameter value. It's going to be the width in the thin dimension, and then we can hit enter. And so now this says fx, which means it's linked to a parameter. The line is fully defined, but it doesn't need to be a traditional line. It can be construction. And now we've got this reference here. Now, I made this reference, and I like to use construction geometry. It's not actually required in Fusion in this case because the slot tool, I can do a center point slot, which means that I could go from the origin and drag this out. But snapping to my reference line means that I've already sort of built out the foundation of it. And then the width of this, or the diameter, is going to be dimension A. And now we've configured that, and we can finish the sketch. Now we want to extrude this. I'm going to go ahead and pull this up. Typically, I use symmetry in my model, so I would typically do this as symmetric above and below the XY plane. For this model, it doesn't matter because I know that there's not symmetry in that direction, so I'm going to build it up in the positive direction. But this is something we always need to think about. This value is dimension B, so I'm going to have it linked to dimension B. And then we can start creating the geometry for those ports. And again, we need to be careful that we reference this geometry, noting that if we went above 2 inches, if we went to 2.5, that fillet would need to be gone. And so if I'm configuring a design like this, I'm thinking about all of the variations, all the dimensions that need to be configured here. And so what I'm going to do is I'm going to right click and create a sketch on that face, very similar to plasticity where we're creating a temporary construction plane. We're just sketching directly on the face. I'm going to draw a circle that's snapped here and snapped to the bottom. And now I can apply my dimension after the fact. Now this is going to be dimension E, but I also need to add in that wall thickness. And so dimension E plus the wall thickness means that we have a consistent wall thickness on the part, and then we can come back and add the smaller diameter that we need to actually create the cut. Now, if you want to add the other circle in this sketch, we can. When I'm thinking about a configurable design, I'm not worried about the number of sketches as much as the thought process in creating the geometry. So I'm going to add it after the fact on the end face. But basically what we want to do is we want to pull this out whatever the distance is. Now, again, this value isn't on the drawing, so I'm gonna make it 1/2 inch. But this needs to go 2 directions. And the other direction, instead of being a distance, I'm gonna say to object and click this object and join them together. But notice that when I did that, it changed this value to negative. This happens sometimes. We want this to be a positive 1/2 inch. And then in the to object section, if this is not giving us the correct selection, always go back and just reselect it. If you ever have problems with this, you can change these to distance. So that's a positive 0.5, and then this one can just come completely in the object and join it. You do need to be careful about the distance that this goes, and we always want it to make sure that it extends far enough into the part. So if you have this problem where it's saying basically this won't work, my typical solution, because this is symmetric about the origin, is to change this to object, and for my selection, I'll use this plane. And so this ensures that every variation of this part as it gets bigger or smaller doesn't rely on some random number for extending that into the part. It's always going to go to that midplane, so we know just based on the way that the part was created that we will always have that overlap or that intersection. Next, over here, what we want to do, and I'm going to hide this canvas because I don't really need to see it. I need to create the geometry over here. Now, one thing I can do in this case is I can create a plane that is tangent to this cylinder, and then I have this offset value here, and in this case, let's just go out 0.375. I don't know why I didn't take that. Let's say 0.375. And now I've created a plane that was tangent to that at the location that I need. So I can start sketching directly here. Fusion is going to save that construction plane in a folder, very similar to Plasticity, where it kind of saves it in that menu on the right-hand side if you do save or store construction planes. What happens with Fusion in these scenarios is that the coordinate system gets pushed to our plane, and so it's not always based at the origin. It's going to be based on the current plane. So we still have Y that we can use here. I want to snap to Y above the origin and come down and snap there. We need to make sure that this is vertical above the origin, and then we need to give it a dimension. And so this is going to be our dimension E again. So that's that diameter plus the wall thickness. And hit enter, and now we've got the correct size. There are other ways that we could go about this. We could make it equal to that other dimension, but everything linked back to those parameters means that we don't have to worry because it's all going to be changed in one location. Then in this case, I'm going to extrude this to object. I'll select here, join them together, and say OK. So in the bodies folder, we should just have one body. Now, something very similar, this is called shell. It's hollow in Plasticity. We're going to select all these faces, and then we're going to use wall thickness and say OK. Now, positive, negative doesn't matter. In that case, the shell tool has inside versus outside or both. So this can be a positive value. Note the FX here because it is linked to that parameter. And the last thing that we need to do, well, a couple more things, is make the reduced sizes here, as well as just add that fillet to the bottom. So what I'm going to do is sketch on these faces. I'll make a circle, and I'll set the diameter as dimension E. And then we'll extrude that with E on the keyboard. So bring that back in, whatever the distance needs to be. I'm just going to say 0.4. Keep in mind that these distances I didn't configure. The insertion depth of the PVC could possibly change based on the size. I'm actually not sure. I never really paid much attention to that, whether or not that insertion depth changes. And in this case, I'm just going to extrude this in. And again, we're just going to pull it in. That same amount, 0.4 gets a little thin there, but that's okay. So now they're both 0.4. And then last is a fillet on the bottom. And I'm going to make this 0.05 and hit enter. So if we go back into our parameters, everything that we created before is in user parameters. Any dimension in a feature, so for example, the fillet, we did not configure that to be a pre-created dimension. It's just D28, dimension 28, D29, And so these values can still be configured. They can still be included. You can add this with a star. You can add this to your favorites up here. And we can also change the name of this. So instead of D28, we can call this small fillet. And that'll have a name, but it's not considered a user parameter because it was created on the fly. Even if you are, I'll just do a simple test here. If I am sketching something and I want to give this dimension a name, I can say line length equals 1, and this will give it a value that we'll see in the parameters list. So if we look down here, the sketch, we now have one that's called line length. When we give it a name in a sketch or a feature, if it's an extrude distance, for example, it will automatically apply that star to the favorites because it assumes you named this, you must want to use it for something. And so it'll end up in the list at the top. But again, it's slightly different than a user parameter. It's not going to have the FX attached to it. It's not going to be considered a user parameter in a traditional sense. I don't need that sketch, so I'm going to delete it, but just keep in mind that that is a nuance that you need to be aware of. So now that we have this, we have the ability to configure it. And when we create a configuration, essentially what we're doing in this configuration table is we're picking features, appearances, physical materials, or dimensions that we want to configure. And there are multiple ways that we can do this. You can come into things like configure the physical material and appearance. You can come to a feature directly and select configure, which will let you grab the dimensions as well as things like whether or not it's suppressed, the taper angle, things that you may not have changed. But what we want to do in this case is use the FX or add parameters because we went through and we pre-decided all the values we wanted to change to make this whole process really simple. So now we've got all the different parameters that are in this canvas image over here. It won't let me turn it on right now, but so basically what we're going to do is we're going to configure everything, dimension A through the wall thickness for the 1/2 inch, for the 3/4, and for the 1. Now, unfortunately, we can't rename these configurations like half. It won't accept that as a name. So what you can do is you can dimension this 0.5. We can add another configuration, and I'll call this one 0.75 for 3/4. And I can add another one and call this one 1. Keep in mind that when you click on these or double click on these, when the blue bar is on the left-hand side, that means it's active, which means as you start changing these values, it's going to rebuild every time. We don't really want to do that, so I'm going to go back up and activate the first one, and then I'm going to manually modify each of these dimensions. So dimension A for the 3/4 is 1 1/2. I'm going to tab over. This is 1 5/8. I'm going to tab over to C. This is going to be 4 15/16. D is going to be 4 5/8. And then you'll notice that dimension E is kind of strange. It shows 7/8 times 1 inch. Sometimes when we are creating dimensions, it needs to multiply it by 1 of whatever the unit is. So it doesn't necessarily have to be in that format, but sometimes you'll see that. And all we really need to do is we're going to do 1 and 1/16. And then again, the wall thickness does change. And just for the purposes of this video, I'm going to go ahead and just change it to another value. I'm going to tab down to here. So for the 1 inch, this is 1 3/4. For dimension B, this is 2 inches. Dimension C is 6 inches. So it actually jumps up quite a bit. Dimension D is 5 3/8. Dimension E for the port size is 1 5/16. And for the wall thickness, I'm going to go ahead and do 0.133. Again, this is roughly how it goes. As it increases in size, it's going to the wall thickness gets a little bit more. I'm not too worried about it for our example. Now that we've got all these punched in, you can test values. You can manually put in values here and see if your model updates, or you can activate these configurations and you can take a look and see how everything updates. The configurations will be listed in this dropdown. And if we try to insert this into an assembly, we'll be able to pick that. In the last What's New video for Fusion, I did talk a little bit about, or I did mention the ability for you to, when you're building out these configured assemblies, there are some new functionality that we have in terms of making some elements of these testable and configurable, making these lists configurable. And I'm not really going to go into that here because it's kind of outside of what we're doing in this video. But if you want to see more configuration type stuff, we can do an update on that. We did our configuration series, like, I don't know, when it was first released. So some things have changed. This configuration rules is only available inside of the design extension, which is where you get access to all these plastic tools. And so generally, if you're on a hobby license, you won't have access to that. If you're on an EDU, you will. If you're commercial, you have to pay for it. So I don't really have any plans to go over that, but there is a lot of powerful stuff that you can do with those. If you're coming from something like SolidWorks, you can think of this a little bit like DriveWorks, but without a panel for the user interface. So it does offer up a lot of flexibility. All right, so time to wrap this up. The main takeaway here that I hope got across is that plasticity and fusion have the ability to create the same geometry. Mathematically speaking, you could create the exact same part. Plasticity has a lot more flexibility in terms of direct modeling and in my opinion, surface quality. Xnerbs in the studio license has a lot to offer, and just generally the quality of the surfaces as well as the flexibility of the model are really high in plasticity. But remember, plasticity is designed to be a direct modeler. It has a Blender bridge, so going back and forth between plasticity and Blender or Blender and plasticity, those workflows make a lot of sense. If you're doing props or animation, or you're basically working in sort of the digital industry, not necessarily the physical industry. Even though we can do 3D printing, we can send parts out to be machined, that's kind of outside of the realm of what plasticity was designed for. Here, inside of Fusion, really we're looking more at, I would say, a more rigid style of modeling where we're planning out each sketch, each feature, and in this case, a configurable model, how it's going to update, how it's going to change. We have a lot of capabilities here to build these robust parametric models, build assemblies, have mechanical joints, and even go into things like simulation and manufacture. Animation is really for exploded views for drawings. You can save the animation, but it's not a rendered animation, it's screen capture. There is some ability to do rendering inside of Fusion. Autodesk is pushing the Autodesk Assistant and Microsoft Azure to do basically AI generated rendered images now. Rendering, you can get some pretty nice results from, but it's not a true dedicated rendering package like you'd find with other programs like Keyshot or Bunkspeed or something like that. But again, they sort of fit different strategies. And if you're looking for somewhere in between, it can be really hard to decide. So hopefully this video helped. If you still have more questions, let me know. Remember that we do have both Fusion and Plasticity courses on our Learn Everything About Design website. I'll leave all that information in the description of the video. As always, thanks for watching, and we'll see you in the next one.